Hello everyone. Am I audible? You can hear my voice, right?
Yes, sir.
Okay. So let me share the screen. Sharing the screen. Well, so this is the lecture of computer vision. I think lecture number 2. Now, in the last class, we have gone through some basic introduction of computer vision, and we have found that computer vision is an interdisciplinary field that enables computers to interpret and process visual data, typically from images and videos. And the goal is to automate tasks like human visual systems can perform. We recognize objects, so our task is to make the machines capable of recognizing objects, right? So suppose uh, this is a pen. So if we have developed a computer vision system, it should be able to recognize that this is a pen. Like we human do, we recognize object. So our task is to make such system which will be able to detect objects and detect, say, faces, recognizes faces. Let's suppose this is the face of, say, Asif. This is the face of Abir, like that. Reading text. Now I'm reading the text, suppose, from the slide. Now system or that particular computer vision model should be able to read the text for you, analyze the skins, like that. So in essence, we can say that computer vision empowers machines to see and make decisions based on the visual world. So that's why the name is computer vision that we are referring for. So we are trying to put vision to the computer so that it can see and make decisions based on the visual world. Okay. So there are different applications of computer vision. Nowadays, you can directly say that this is the era of AI, right? AICT declared this year as the year of AI. So AI basically composed of mostly of computer vision. Everywhere we are using. You can see here, this is a good peek. It's like defect detection. One project means one project that I have given to my students, that semiconductor defect detection. Why? Because in Assam, semiconductor industries are coming. Nowadays, growth is really happening, and so many industries are coming. And one among them is the semiconductor industries. Okay, if it is built up, means in a well and good manner, then obviously we can expect that we don't need to depend on China, right? But in such industries, what happens? Usually, it's from some defective products. So that may hamper the total production. There also, our area can help to detect those defects. And this is a very important thing. So that's why I have written one paper for my students, and they have presented in an international conference, and they got the prize also. They got the third best prize. Means among all the ITians are there, and everywhere the members from other universities are there, but our university students got third prize. So this is a very good thing. Now there we have targeted that defect detection. Similarly, metrology, right? Then into the metrology, you guys know now what we do in metrology. Yes or no?
Yes, sir.
Okay. As an example,
Sir, we see the condition of the, you can say, climate, seasons, and weather.
very good. So you are correct, Sahil. So what happened? Say we want to predict that whether the wine is flowing towards south or towards, suppose, north, right? That can be also possible through computer visions. Okay, the numerous satellite images are there, that real-time images are there. From there, we can detect. Suppose hurricane. Okay, this type of disaster can also be detected. Suppose some kind of flood, that flash flood. I hope you know that flash flood. That is possibly detected through computer vision. If we can detail, if we can build up some such effective algorithm. Okay, effective models. Then intruder detection, assembly, verification, screen reader, right? Screen reader is very good example. Code and character reader, then robotics also. So there are different applications of computer vision. Right. Again, I have written few specific application like face recognition. I have given one project to Sahil Group. Sahil Group, all of you members are here. I hope you are here, right? Sahil is there. Other members?
ছাৰ
Sahil?
বাকী কেইজনক নাজানো ছাৰ।
Oh, very good. Okay, no problem. So that is a very good example of computer vision itself. Our motive was to first detect that who are the responsive students who are really actually concentrating on the study, but those students who are sitting in the classroom idle or their mind is in somewhere else. So that means we are trying to monitor the students' attention. That was our project, Shahid, right?
য়েছ ছাৰ।
Okay, that is a very good project, of course. So it actually depends how much we can complete. Then object detection. Object detection, how many means many examples we have given, like detecting objects within images, video stream, autonomous vehicle, surveillance, inventory management. Many places we need to detect the objects. Segmentation, image segmentation means we divide the image into different groups so that we can put more focus on that particular group or clusters, or you can say segments. And we use it in medical imaging field, like tumor detection, satellite image processing, right? Suppose we need to detect whether the means status of a river in a time series data says, suppose 2000, what was the status, means how means its banks are actually eroding or it is the same case. Okay, erosion detection, I mean to say. So these things can be possible through segmentation. Then augmented reality. Augmented reality means AR, overlaying digital information onto the physical world in real time. Today's means generations, they like playing games through AR, right? We can even go for advertising, and on all education also you can study history through some AR based digital book. Okay. OCR means optical character recognition. We convert image into text, means some editable text that can be used in document scanning and reading the signs in the images. Then motion tracking also, analyzing movement in the video sequences, crucial in sports analysis, robotics. So these are the specific applications of computer visions. Out of you, suppose some of you are very much interested in computer vision, you can go for these different areas. And there's a very good career prospect in this particular area. Now let's come to our main input, that is digital image. Computer vision is possible because of the image, right? So what is the digital image? How can we define a digital image? Can anybody just give a small definition?
The combination of pixels.
Combination of pixels. Okay, good. Anyone else? See, I have just pronounced digital image, right? Digital means what? We are dealing with what? Some kind of pixels, some kind of, you can say, Huron values, right? So we can define digital image as a two-dimensional matrix of numbers that represent the light intensities of different pixels in an image. Right now, can you see my face here in this video?
Yes, sir.
You can see now, right? But if I come to this place, suppose if I sit like this, can you see my face? I don't think it can be possible properly. Yes or no? If I sit in a
Yes, sir.
position like this, then I don't think that you can see me properly. Yes?
Yes, sir.
So I want to know the reason why this is so.
So because of the light.
Because of the light. Very good answer. Because light is the source of our image. If light is not there, our intensity values will not be some kind of actually representing the same. It may be idle, or you can say zero. So to form an image, what is the most important thing we need is what? Light. Got my point? And this digital image is nothing but a two-dimensional matrix of those numbers which represent the values of this light. And this light we can call as, light values we can call as what? Intensity. Are you getting my point? What we can say? Intensities. So intensities means the light value. Suppose currently this light is hitting my face, and this portion's image is more proper than this portion, because light is not coming to this part. बुझी पाइसा? समझ में आ रहा है ना? Okay.
Yes, sir.
Yes, sir.
So while you are defining, you have to properly use this term. A digital image is a two-dimensional matrix of numbers that represent the light intensities of different pixels in an image. And we can keep them in different formats, like joint photographic expert group format, portable network graphics format, right? And TIFF format. Many of them are available. And these are different formats as part of different requirements. We need to input in, suppose, compressed form, then we can go for some JPG. Suppose we need to put in a good format so that the information will not be lost, PNG. So similarly, you can choose your own format, right? We can use them for processing and analyzing. So that was the definition of a digital image. Now, in this particular image, you can clearly see now what I have just said, right? Okay, what you can see now?
That is 6x6 matrix.
Very good. 6 into 6 means these are 6 columns, right? And these are 6 rows. Okay. Now, 6 cross 6 will be the resolution, right? 6 cross 6 will be the resolution. And in 6 columns, 6 pixels, and 6 rows. So total pixels 36. So in each of them, some value will be there as per the light quantity. And these are the intensity values. And each of them will be the pixel element, that is pixel. I hope the digital image definition with all its terminologies is clear to you.
Sir, I have a question, sir.
Of course.
Sir, the range of the light, that is the intensity, is it defined for some range, or we can means modify it by ourselves?
Of course. See, first stage is the image acquisition phase. Means right now light is coming and hitting me, and I have taken one, suppose, analog image, right? I convert it into digital image. Now, while converting to the digital image, it will be the capacity of our storage system, that in how much capacity we are going to store it. If the values are good, then we can store the whole image in that without losing any information. That is one part. Now, what he said that the range of values, suppose range of values means what? We have an image and that may be color, that may be black. I will go through different types. Okay, just I'm taking simple color image. Now, in a color image, there are 3 channels, say, and every channel has some range of values. Now, depending on that how the lights are, quantities are, these values also be changed. Are you getting my point? And according to the values range, the image quality will be different. Now, also, you can work upon that. We used to call it like editing an image. Yes or no? Editing an image means we try to just modify the values of those different channels, those intensity values with respect to every channel. Accordingly, we can expect that a better quality image can be formed. Maybe the raw image is not such good, but after manipulating those different ranges of intensity, you can have a slightly better quality image. Are you getting my point, Avir?
Yes, sir.
Okay. Is it clear now?
Yes, sir.
Okay, don't worry. There will be different terms. When the class progresses, we'll go through them. Well, now first term is pixel. Yes? What is that? Pixel. Pixel stands for picture element. Element means what? What do you understand by element? Element means simple unit, right? Any simple unit. Suppose this is an element of pen. Yes or no? Similarly, for the whole image, if we consider the smallest unit, that is our pixel. Got it? For the whole
Yes, sir.
image, if we consider the smallest unit, I said what? Smallest unit, then that becomes our pixel element or pixel. And this pixel represents a color, if it is a color image, along with some intensity values. Now, I say that there may be different types of images. Images may be black and white. Have you heard about black and white image?
Yes, sir.
Right. So black and white image means what? You don't think that, you don't means consider black and white image as a gray image. Both are different. Just few minutes before, Abir asked one question, that is ranges of value. That will come under grayscale image. Are you getting my point? But black and white image will have only 2 values. One is white, another is what? Black.
Black.
White means the maximum of, suppose 8-bit I'm considering 255. Black is the lowest one, 0. So in a black and white image, either 0, every pixel value I am talking about. Are you getting my point? Everyone, are you getting or not? Buji paisa?
Yes, sir.
Okay. So every pixel either may be 0 or maybe 1. That is a black and white image. Now what happened? Grayscale image, where we are slightly taking more ranges, not just 2 values. We can consider, suppose for an 8-bit from 0 to 255. 0, black, 0.1, you can also take, but you can just take 1, slightly good, 2, like that. This one you don't consider as that one of black and white. Black and white, 0 and 1, that is the binary one, binary image. Here I am taking 8 bits. So how many values are possible in an 8-bit?
256.
Very good, 256. Okay. So 0, 1, 2, 3, like that. We are moving from black towards slightly black, less black, like that, going towards white, white, more white, at the maximum white. So that is our grayscale image. Now, color image. In a color image, there is a combination of 3 channels, R, Z, B. I hope you can see me in color now, in color format, right? My color image, video is nothing but the sequence of images, right? Color image. So this means 3 channels are working properly. Yes, can you see the color of this? What is the color? What is this color? Red.
Red, sir.
Red, sir.
What is this color? Black. Okay. So what I mean to say, now you are properly seeing the 3 channels. If I remove one channel, then you will not be able to see these colors. So in a color image, every pixel, you will find 3 channels together. R, that is red, Z, that is green, B, that is blue. RGB channels. I hope it is clear. Now, look at this image. I'm considering again 8-bit. We have how many channels? 3 channels. R, Z, B. So you can see here, every channel, the values are what? From 0 to 255. Okay, so 1 pixel consists of these 3 channels. So these 3 channels together, they form 3-dimensional coordinates. Okay. Now, next technical term that you should know is resolution. Have you heard this term before? Resolution?
Yes.
You means in what cases?
What's the resolution of the windows or the screen?
Means to, if I have less resolution, means what?
Image is less clear. It's you can say it's not high resolution. High resolution means more clear image. Less resolution means less clear image.
And how have you thought that why it is like that?
Because resolution means the number of pixels in a image. So if the number of pixels is more, so that means we get more amount of light in a image. If the resolution is less, that means we get only basic number of light in a image. So more number of light means more details.
Very good. That's the correct answer. So resolution means number of pixels in an image. What I have said, number of pixels in an image. You know, in a screen, this is the width and this is the height. Buji paisa? Are you getting my point? If we multiply them, width cross height, width side this mass of pixel, height side this mass of pixel. As a whole, we will get what? Total number of pixel that is possible in that particular screen where we are depicting our image. So don't forget, resolution means the number of pixel. Higher resolution means what? It contains more detail, right? More details because more number of pixels are there. But of course, for that, we need what? More storage. Is it okay? Now, what this image
Yes.
says, from this image, what you got? ये इमेज 2 पढ़ा ये इमेज से क्या समझ में आ रहा है आप लोगों को?
The number of resolution is higher than the quality has like 4K, 2K, and it reduces, then the quality of the image also reduces.
Very good. SD, you can see the maximum resolution possible. This one 640 into 480. 640 means what? Width or height?
So with
Good. 1280 724 SD. Full SD 1920 into 1080. You know na 1080 720, right? I hope you can see it. Yes or no?
Yes, sir.
yes,
Yes,
sir.
We used to set it for 360, then 720, 480 like that. Yes. কিমান আছিলে? In YouTube, how many different resolutions?
220,
144.
723,
360.
360.
Yes. So you can see when we increase the resolution, our picture will be more and more clear, right? And 4K, that is 3840 and 2160. If you go for competitive exams now, they used to ask the MCQs on these values. So just slightly remember that at least 4K1 is the A1. 4K, that is 3840 into 2160. And they also ask that what is the width value and what is the height value. So what is the height value of 4K image?
2160.
2160. And for full HD, it is 1010
80.
80. Good.
80.
Very good. Now, then we have image representation. We may have grayscale image. There will be single channel, but the values will be through a range like 0 to 255. RGB image, there will be 3 channel, red, green, blue. Each of them have different values. Then one more channel, if you include alpha channel for transparency, then that becomes RGBA, making it useful for images with transparency. Transparent, if we make it transparent, it is visible, right? So there are different image representation. I'm just including these three of right now. Now, the next part is image formation. Image, how image form, you just got it because of the light. Images are formed when light from the environment is captured by a camera. Camera have lenses that focus the light onto a sensor of film where the captured light is transformed into an image, right? So this is a kind of, you can say, optical property, right? And what we need for that are camera. Of course, we need a camera, right? Camera collects light through a lens and records it into its sensor. In our mobile phone, these are the sensors. So the most common types of digital camera we have today is CCD, charged coupled device, and CMOS, that is complementary metal oxide semiconductor sensors. And this one is mostly used. Lenses are used to focus light onto the sensor. Okay, then they control the amount of light entering the camera, can affect the sharpness, field of view, and depth of the field of the captured image. Then projection model, how you are projecting means this wall is a multi-dimensional, but we usually consider 2D and 3D, right? That can be possible through projection. Simple model is you can say here pinhole camera model, which assumes that light passes through a small hole to project onto a flat surface. No need to just worry about that. This is just, you can say, projection. Now, if you consider less storage, so less bits are possible. If less bit means what? Less depth. If depth is not there, you cannot expect a good valued or good quality image. You can see here, this is a 2-bit one, the 4-bit, 6-bit, 8-bit, 10-bit. Can you see the difference in these images?
Yes, sir.
Okay. What is that difference?
Sir, the contrast or the amount of shadows, it varies from 2-bit, 4-bit, 6-bit, 8-bit, and 10-bit.
Okay. Contrast. He said contrast. One more thing I would like to know. Can anybody say what else you can see here? What is the difference?
The clarity of the image.
Clarity. Very good. Clarity also. So overall, you can say if the number of bits are increasing, depth is increasing. If you can see a good sensored camera like Samsung or in iPhone also, you can see the depth management is there. Have you experienced that?
Yes.
While taking a
Yes, sir.
picture, have you experienced the depth means manipulation in, say, Samsung or iPhone cameras? Smartphone cameras, also, of course. যদি পোৱা নাই, at least you try to check it. If you see, if you have a smartphone, nowadays we all have the smartphone. If you have a device now, just try to utilize it fully. Okay, मेरा यही रहता है कि जो भी डिवाइस हमारे पास है हमें कंप्लीट यूटिलाइज करना चाहिए. If you have an iPhone ना, if you have an iPhone, try to utilize completely that sensors that it carries. Similarly, if you have a Sony, because Sony is the above all, means Sony sensors are, like most precious one. And in maximum nowadays smartphone, they try to actually bring Sony sensors to their camera so that they can expect a good image. So if you have a device now, so you just try to experiment this that if you changes the depth, that what type of differences you can see. Okay, you can do it as an assignment, the depth representation. This subject computer vision is very interesting. Whatever we are dealing now, all these things are practicals. So if you take it interesting, you don't get bored. Well, so I'm going to conclude the today's lecture. Whatever I discussed today, everything clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. Then let me take the attendance. Oh, 2 attendance I have to take. Okay. 1. Roll number 1, 2, 3, 4,
Present, sir.
Present.
3 present, sir.
5,
4 sir.
5. Roll number 5, 6, 7, 8,
Present, sir.
9, 10, 11.
Sir, 9 present.
Okay, 11, 9, 12, 13.
Yes. Yes, sir. 12.
Okay, 14.
Sir, 13 present.
Okay, 14, 15.
So 14 nice, sir. Present, sir.
Okay, 15 tomorrow. It is showing pending due. Okay, no problem.
Sir,
You contact ERP, otherwise attendance will
sir, মই
be.
কৈছিলো sir, এই এলপিনত ক্লিয়াৰ হৈ গৈছে.
But here it is not. You call him after this class that still my status is showing in violet color.
Okay, sir.
16, 17, 18,
17
Yes,
present,
sir.
sir.
Okay, 19,
Present, sir.
19, 20.
Yes, sir. 20.
তুমি ঠিকে আছা নহয় ন বেছি প্ৰেছাৰ পাইছে নি আকৌ তাত
নাই, sir.
ভালকে পঢ়া শুনা কৰা
Okay, sir.
ওকে 21
Present, sir.
22
Present, sir.
23
Present, sir.
24 মিলন ক'ত আছা এতিয়া
Sir, মই ইয়াতে ৰুমত আছো sir, আবি আৰু মই মাজত।
আচ্ছা নিষ্টত নাই নেকি এতিয়া
নিষ্টতে কৰি আছে sir। আৰু ৰুম লৈছো
মানে
যে আহি
এতিয়া নিষ্টত
নিষ্ট
আছা
আছে।
নে মানে ৰুমত আছা
sir আহিলো নিষ্টলে 4টা বজাৰ পৰা 4টা বজাত আহিলো।